Hello everyone, welcome to the Cassandra Cloud Native Workshop series. I'm Aleksandr VOLOCHNEV, today with me Erick RAMIREZ and Jeremy Hanna, and we are going to speak about the testing for your NoSQL application and specifically for Cassandra first of all. Hi Erick, hi Jeremy.
Hello, how you going?
Yeah, that I see that
How's
should
that?
be good. So, could you please confirm what you hear us loud and clear so we can start? All good, perfect, perfect. And so to introduce ourselves in just 2 words, you know Erick already. Erick is our question master and answer master at the community.datastacks.com and one of our greatest experts in everything related to Cassandra. And well, you know Erick already, you've seen him, but Jeremy is a new person here, let's say in our studio, virtual studio. So Jeremy, could you please introduce yourself?
Sure. I'm Jeremy Hanna. I've been at DataStax for about 8 years now in the Cassandra community since about 2010. So happy to help out in any way that I can. And we're discussing a subject that is a fascinating topic of benchmarking your data models. And I worked on the team that put some of these tools together, and we've used it internally for the last about 5 years, and so hopefully that can give everybody a little bit of background.
Yep. So as you see, we are really lucky to have the person like that here. And you know what? This series, this workshop is very important because, well, Cassandra gives us a lot of great benefits. But with the data model done wrong, you can ruin everything. So testing for your data model and testing with NoSQL bench, specifically in this case, is a very good way to set up your database to be efficient. So let's move on. We said already about the crew, so you see some people at the screen, but there are more people actually answering questions at Discord and YouTube. So that's the full team working with you today, except of David. David is sleeping because he's in the United States, I guess. And see you next Wednesday with other guys. And so what's happening today here? That's workshop series about the cloud native applications, not only Cassandra. If you are with us for a while already, you know what we did. Apache Cassandra at weeks 1 and 2. We did microservices and REST API applications at week 3 and 4. Weeks 5 and 6 were dedicated for Kubernetes and Cassandra in Kubernetes and our application in Kubernetes. And now we are at the week 7. It's all about testing, all about checking if your database is ready to handle the pressure and work efficiently. And week 8 is going to be about the cloud systems like Google Compute Engine and others. And well, hopefully after that you will be much more cloud native than you were in the beginning. And some of housekeeping and setup. So don't forget, we use multiple resources because this workshop series involves multiple resources and tools. We have live streams at YouTube and Twitch. If you prefer Twitch, you may watch us there, but we usually don't answer questions there. We don't have so much people to answer everywhere. We prefer Discord. So for live questions, the best place to be is the Discord, and you may ask questions at YouTube chat as well. For the materials and help, everything is published at the DataStax community. So community.datastacks.com. We have big resources set at the Cassandra Workshop series at the DataStax Academy. And our main hero for the weeks is Astra, Cassandra as a service. And today our main tool is going to be KataCoda. If you don't know what the KataCoda is, have no worries, it's very fine. It's a very nice tool to do exercises and trainings and learn something new. And KataCoda is not only about the Cassandra, but there are a lot of different learning tools and learning ways to work with very different technologies.
Lots of Kubernetes tutorials there as well.
A lot regarding Kubernetes as well. Exactly. Good. So,
and if you're all wondering where all the links are, it's just right on the screen on my right shoulder, bit.ly/Cassandra Workshop Materials. Because I know that lots of people are always asking where the links are.
And yeah, all the materials you can find, well, that's a short link, bit.ly/Cassandra Workshop Materials. That's on the screen close to Jeremy. And now, to do the exercises for today, you will need to sign up at KataCoda. It's a great project, free project for you, and that's a really good place to check out the courses they offer. But now, very important, if you will try to watch the workshop today and do KataCoda at the same time, mostly probably you will fail at least at something, or maybe at the both. So we do ask you, again, we do ask you to first watch the workshop and then do the exercises. And if you are afraid to have your questions unanswered, please have no worries, because again, at Discord and the community.datastacks.com, we are here for you. Good. So, NoSQL Bench. Today we speak about testing a data model and making some pressure on Cassandra with that. And the main tool for us is the NoSQL Bench. What is it and why we think of doing that? NoSQL Bench is a performance testing tool for the NoSQL ecosystem. It's not only for Cassandra, but it supports different drivers, so you can support and you can test very many different systems you may want to have. You may want to test, and that's what makes it great, and it's open source tool. So today we obviously going to test NoSQL Bench with Cassandra, and there are very many different ways to use NoSQL Bench with different bases. You can work with Astra, you can work with Mongo, you can work with DataStax Enterprise, you can work with Kafka, and many others already there and many others to come. So why benchmark? Because there are situations and data models, then your database will look like this track on the right, and if the data model done wrong, however good Cassandra is, if you have hotspots, if your data model is not perfect, some servers are busy and some are idling, you never can be successful. And moreover, you want to know you want to know that before doing your deployments in production. So you want to do benchmarking of your data model before pushing any changes to the production. You want to have it all on the staging as well to be able to test it all. And well, it's very not easy to do, because if you don't have proper tools, you are going to be in deep problems. So NoSQL Bench.
Can I just add something to this?
Of course.
So the NoSQL Bench tooling makes it very nice to say, I have a cluster that I've stood up and I'm wondering how far I can push that cluster. And then I have my data model that I know that I'm going to have, and I want to generate data against the data model and push that against the cluster before I even start putting real load on the cluster. So I can test to see what throughput I can get. I can test to see how it's going to affect the cluster at different read-write ratios, all sorts of different things. And then I can also test it when it comes to how is this going to be affected by having 100 gigabytes on the server versus a terabyte on the server. So all these different patterns you can test with NoSQL Bench with detailed results.
Yep, thanks you, thanks Jeremy. So well, and yeah, that's NoSQL Bench is not just a single tool, but we can say it is together as we will use it today. You will see we have kind of an ecosystem of tools working together. So all of the tests shown by NoSQL Bench you can see in the Grafana, for example, at the right screen. So you can see everything not just in the numbers but already visualize it. So this tool is very convenient to go with. Okay, so a lot of words, but let's speak about how we execute commands. And you have two tools to do that. You can do it locally at your laptop, or you can do it on KataCoda. Today I'm going to do it on KataCoda to share it with you and to see how we are doing that. So if you are doing it locally, not now, but after the workshop, as we said, you can go at github.com, Data Stacks Academy, Cassandra Workshop series, go to week 7 and step 1, executing commands. And I'm going to go to katacoda.com, Data Stacks, courses, NoSQL Bench, intro, NoSQL Bench. Yep, good. So I will start scenario. It will take a moment to set up the things. Now KataCoda will start up Cassandra. I will make it a bit bigger. How KataCoda works, why Cassandra starts, we have a moment. On the left side you see the instructions and steps. On the right side you see terminal, and that's like a command line terminal you may be using, hopefully you are using already, I guess. And on the left side we have instructions like what we are supposed to do. And as Cassandra is running already, first command I want to execute will be a node tool status. And instead of copy pasting, I can simply click on this command and it will be executed automatically. Very convenient. Thank you, KataCoda. Okay, so we see what something is happening. Let's take a look what we have. Node tool status, if you are not familiar, but you should already because it's week 7, we have data center 1, we have one node, that's enough for us for a beginning, and it's in abnormal state at the local host, and well, it seems like it's operational. Now we are going to download the NoSQL Bench. I simply press this button and it makes wget to download the latest release of NoSQL Bench. So it's going to download NoSQL Bench for me. And installation of a NoSQL Bench is a very simple thing. I first download this executable and then I just set the permissions to be able to run it. So I set it up as an executable file. If you are a Linux guy or girl, you know that already. If you don't know what's going on here right now, answer is very simple. I simply set up an execution beat for this file we downloaded. So it's so it to be executable. Very well. And now we can do a very simple workload, very simple test. We prepare it for you. We can start it with nb SQL IOT. So nb is the command to run NoSQL Bench, and SQL IOT, sorry, it's something we prepared for you, and we will make a deep dive into that in some seconds. Good.
I just want to chime in and say on Windows and Mac, on Linux, this is a pre-built bundled JVM with NB, which is an executable. On Windows and Mac, you download the nb.jar, which is in the course materials, and you'll be running java-jar, nb.jar, and then the commands are identical. That what Alex is saying right now.
Exactly.
You do need Java 14 16 on Windows and Mac.
Thank you, Jeremy. Yep. So it will take some time. I just wanted to show you how do we run that. So at this moment I will stop it. I don't need it right now. And benchmark creates a key space we use to analyze the data. So in this case, I want temporarily to remove this key space just as a little cleanup, because we don't need it at this point. Okay. And first step is over. We just downloaded and executed our first NoSQL bench command. So we want to do some more things. In the previous step, we run a prepackaged benchmark. In the remainder of this scenario, we will show how to unpackage and customize tests, because, well, you don't need our tests. You want to have your own tests for your data. First, we will start by creating a schema for our test. So, real Cassandra workload, read and write to tables. Our simulated benchmark workload also needs tables for the read and write activity. The schema we are setting up is the target for the simulated workload. What does that mean? We just need some data and real schema to execute the testing. And first we execute this command. That's nb, so NoSQL bench, run, driver. Driver will be SQL, because, well, we are working with Cassandra via Cassandra query language. And workload will be SQL key value, and we run only text face schema. So I don't run the full workload and all the big scenarios, but only the face schema part. Good. And there is a question, what's the workload file? In our example, SQL key value is a file what is bundled into the executable. This file describes the various operations our test will perform. If you want to see the file, you can extract it with nb copy SQL value. We don't run through this file in this scenario, but we want you to know so you can extract this workload from the nb if you want to research for that. Good. So something has happened, and let's see what's in the baselines now. Okay, so we created some tables. And what tables do we have? Well, first, baselines is a simple key space with simple strategy replication 1. So nothing, no surprises here, as we have single node cluster. And we have baselines key value table with key and value. So it's going to be pretty simple example for us, this one. And that's all there to creating a test schema. So we prepare it for that, for testing. At the step 3 of the KataCoda scenario, we are going to write some test data. So we have schema, but now we want to have test data. Let's load some data into our newly created table. As you may have guessed, we can use NoSQL bench for that too. Before we load the data, we want to review the activity NoSQL bench will generate. We do this by setting driver as to the out. Give it a try. So you remember the last command we did was driver SQL, so Cassandra query language. Everything what we did was executed as SQL in the end. But now we set driver as to the out. It's very good and very convenient for debugging things. So start is like run, but asynchronous, where run is synchronous. Driver as to the out says push everything to the as to the out, not to Cassandra. Workload, we specify which workload we are going to use. And text phase ramp up, it's the target. So we do only part of the whole workload. And cycles 10 tells how many times to run the target. So this phase ramp up. We will dive into the files in a moment. Good. And we see, so that's my output. It's very simple. That's basically going to insert some data. And we can now
So just to reiterate, this is with the driver set to stdout. If it was set to CQL, it will execute CQL commands. But when it's to stdout, all it will do is just display to you what it's about to do.
Yeah,
And
like a dry
one
run.
important point to talk about here is that the data that it generates is deterministic, so you can run it as many times as you want. It will always generate the same amount of the same data, the same values.
Right. It's random with the distributions that you specify. When we look at the recipe, you can get a feel for that. But at the same time, when you do count equals 10, between 1 and 10, if we ran that same command again, it would have identical results. And that's important when you're doing benchmarking, because then you're not wondering about, okay, is the random distribution different this time than last time? And that's all based on the cycles. The cycle is the seed for the random data. And so if you're on cycle 1, that'll be the random seed, and that will generate the same values on cycle 1 no matter what.
Yep, great. So now finally I want to load this data to my database, and to do that I have to update driver and set it instead of stdout, so not just print the commands but execute them, and instead of stdout I say CQL and it will help me to do all the job, allot the data to Cassandra. It's ready, and now I want to see what's in the database. And well, all my values what were prepared and deterministically prepared, as you've seen here, they are with me. Good. So now we have data in our benchmark model, so we can move on. To proceed with that, first thing we do the real benchmark for the data we prepared, schema and data already. Let's run it, and it may take some time, so let's walk through the steps I'm doing here. NB start, driver CQL, workload CQL key value, tags, phase main, cycles 100,000, cycle rate 5,000, threads 50, progress, console to second. And indeed, we are seeing some progress happening right now. While it's going on, let's walk through the options we gave. So, start executes the workload statements asynchronously. Okay, we covered that. Which workload we are going to use? SQL key value workload we prepared. Tags phase main. If you run it like without tags phase main, it's going to execute the full workload, but don't forget we already prepared schema and data, so we don't have to do it again. That's why we specify with tags we are going to do only the main phase and do the test by itself. Cycles 100,000. It tells NoSQL bench to run the section 100,000 times. Okay, clear. Cycle rate limits the test to 5,000 operations per second, and we are going to do it in 50 threads, so for the proper concurrency. And progress console to second is very simple. We are setting progress to a console, so you see what's going on right now, and 2 seconds means what we are going to update it at this rate. Good. And the benchmark is almost done.
So just to reiterate, so the tags makes the determination in terms of when you specify which phase in the YAML or in the workload you want to execute. So typically there's 3. So there's the schema phase that Alex was talking about, where it creates the table schema. There's the ramp up phase where you're inserting data into your tables, and then the main phase, which is when you're actually doing the load testing work, the benchmarking work.
Good.
Yeah, one other point for that, the phases, so you have like a schema set up, and you have things like ramp up. So if you're saying, okay, I want to have like when I'm doing my load testing, I don't want to load test into an empty database, right? I want to have a ramp up phase where it kind of puts some data in there, because there's background processes that happen once you already have data. And then when you're querying the data, if you're getting empty data, that's kind of an outlier in terms of performance. And so a ramp up phase is meant to give you a baseline of data before you move forward. So you can have like, 1 billion data points to start off, maybe, or 100,000 data points to start off. And then what the main phase might be is to say, now that we've gotten a baseline of data, let's push this and this would emulate or simulate normal operations against the cluster now that you have kind of some data that's already in there.
Yeah, thank you so much, Hal. We are really lucky to have you here with us. Good. And so now we have this test executed, but we don't have any interesting results so far. So let's move on to the next step and the last step of this introduction into NoSQL Bench. Understanding the results. When we run the test in the beginning, NoSQL Bench tells us about logging. So here we see in the every scenario we have logging to logs scenario blah blah blah. So that's going basically to be the year, month, date, and so on. And all the results are written there. Good. And I will not recreate it because we just did that. I will move on, and I want to see the log file and see some performance metrics. So wait a moment, I need to remove old logs, and where it puts them. Logs, of course. Oh my god, logs. So I will switch to this folder, and we have some old logs here. So I'm going to open the last one, and the last one was this one. So my command will be to open the file, but instead of opening all logs, I will open the last log, and that's going to be okay. Of course, I am already in the logs folder. Good. Scenario. Up. Good. 41. Yep. Good. So with our grep time timer, we see some first results here. And Jeremy, would you say, would you have a word on what's the most important for us here?
Let me move out of the way.
Thank you.
So you can see that there's a variety of different metrics that are being tracked at any given time. Let me get back to, so you have like P99. So if you're interested in the P99 or the 99.9 percentile, then those are obviously, you need to make sure that your read queries, for instance, or your read-write mixture happens within that range. You can also see the max and some of the statistical details that you might be interested in.
Thank you. Eric, you can get back.
So we've got a really good question out here. So what's the difference between NoSQL Bench and YCSV?
I can take that one. It's NoSQL Bench is really meant. We saw a lot of deficiencies in how YSCSB was kind of. You can always mess with statistics, and you can always kind of fudge the results based on what you're doing. So we noticed that it just wasn't as flexible as it needed to be. And this was kind of a way that we could contribute to the community in terms of having a standard way that was very true to the data models and true to the data stores in terms of benchmarking. YCSB was a good effort, but I think that this addresses a number of the shortcomings that YCSB had.
Okay, so let's move on. So first I have two things to say here. First, some of you maybe, oh okay, I got it, percentiles, results, 99, 95 and so on. And some of you must be, what are all those numbers? That's always like that at these workshops because we have people with very different background. So first of all, don't be afraid of those numbers. They're basically very simple, and they specify like how many of the queries received the answer within some time. So percentile 95 means what 95 of the queries received the result within this time, and percentile 99 received what 99 of my queries received the response within not higher than this time, for example, but still not very
right. So in this example, it's 702 microseconds, so it's less than 1 millisecond.
Indeed, I should have specified the measurement unit, so it's milliseconds in this time. And last thing, those numbers are convenient to use only for people with a very, very huge experience who can read that easily, but we want to have things easier. NoSQL Bench is very well integrated with Grafana to have it all visualized, and we will see it very soon. Next exercise. We are going, so we did some commands already, that's great, but well, we want those commands to be more well visualized, and we have some great tools to do that. So to watch some metrics and to watch some results and pressure on your system, we will use some external tools. And today we speak about Grafana and Prometheus. Some of you may be familiar already with them with the last workshops. We used them to watch some of the results and system states at the last workshops. But if you didn't, that's very fine. It's easy to say. We have Grafana is a great visualization tool. Basically, you can give to it any kind of data and say the way how it should be visualized and which kind of graphs be visualized, for example, and you have it very nice. You will see it in a moment. And also Prometheus is a kind of a database we are using to collect the data to show it later in Grafana. So to do so, I'm going again to the KataCoda, and we have it data stacks, courses, NoSQL Bench intro, NoSQL Bench Grafana, and we also have all the required things at the github.com at DataStax Academy Cassandra Workshop series. But don't dare to do it right now, do it after the workshop. So I'm getting to KataCoda, and I start this scenario. So what we will do here, we will run NoSQL Bench against the Cassandra cluster and view the stats, and that's a very interesting scenario. Actually, that's my favorite scenario for this workshop, and you soon will see why. So we are getting ready. We start up Cassandra, and we run NoSQL Bench very soon. So It may take a moment.
So while that's loading, it's not just the NoSQL bench that we have on KataCoda. We've got some quite a number of tutorials for, say, your first Java application. There's some data modeling stuff in there. We're porting some of the Academy courses as well onto KataCoda, and you can access them from datastacks.com/dev.
Exactly, thank you, Eric. So, okay, I have my Cassandra ready. Very well, and I'm going to execute node tool status to see what Cassandra is up and normal. So Cassandra is here and ready to do the job. Now, I do interesting thing. I run the command which looks pretty familiar. So NoSQL bench, SQL IoT, cycle rate 100, progress console 15 seconds, Docker metrics. Something looks familiar here, like cycle rate or NoSQL bench or progress console 15 seconds, but something is new, and that's the Docker metrics. It means it's a built-in NoSQL bench command, which means we will export statistical data so we can see it in external tools like Grafana. A NoSQL bench supports different metrics and different reporting methods, including CSV if you may need that, and HDR, but the Docker metrics is the easiest to use and definitely easiest for us to use to see the results, easier to see, yes. Don't know how to say it better. So, we have benchmark running. We are going to look at the stats. With the Docker metrics option, NoSQL bench downloads and launches some additional Docker containers to support Grafana. So we don't embed Grafana to this NB, but we use it as an external tool, which we run with Docker commands as a Docker container. And in the log message, we see something already, what we have Grafana and Prometheus running and available in our browser at 3000 and host 1990. And we have them right here. And we have Grafana here and Prometheus here. Okay, Prometheus looks a bit unready, but for us the most important thing is Grafana. And I'm trying to log in. It was admin and password. What was the password? Secret.
Admin as well.
Yep, good. And I will not set this one. Admin as well. Yeah, correct. And Grafana is here, and it set up the step. No, I will not change my password. Never mind. Good. So we click to home and we go to NoSQL bench. Wait a moment for me. It's a little bit okay. I think it will be easier to use like that. So I open the same Grafana but in my normal browser window. And I will make it a little bigger for you to see. Yes, now it looks better. What I want to do is to find, okay, we are at home already, but I don't see my NoSQL bench. Search dashboards by name. Grafana fundamentals. Make your first dashboards.
Can you just check in the terminal?
Yes, I think I have to, because, well, I don't see my...
Yeah, you might check to see if there's
oh, something wrong. Okay, something went wrong.
Yeah, so what happened is that your session expired from the looks of it. So you might need to just refresh it, refresh the browser and start again, yeah. So you guys will notice that that will happen too, that if you're idle for a bit, your KataCoda scenario will time out. You just need to refresh.
Well, then it's even good what it's happened. Yes, it may be easier with your local environment, but well, that's definitely, in this case, you don't have to, if you go with KataCoda, you don't have to install all the things on your local machine. Maybe we have some questions to answer at Discord or YouTube while my KataCoda is starting.
Yes, so one of the questions on Discord that Jeremy answered is when we install NoSQL Bench, does it install Cassandra? And the answer is no. So when we're doing the KataCoda scenario, we're preloading stuff for you so that you can just easily get started doing stuff. So we do the same thing for, say, like when you're trying out CQLSH for the first time, and when you do a CQL scenario, we preload a Cassandra instance in the background so that it's ready to go by the time you're ready. Next question is Prometheus for performance metrics. Prometheus collects the data, so it works with things like collectd to collect raw data, and then we send that data to Grafana. This isn't a DataStax technology, nothing to do with Cassandra. So if you were monitoring stuff with Prometheus and collectd, you can send that data to the Grafana, and Grafana will help you visualize the data and do aggregates like graphing and stuff. How do we do performance tuning? There's a metrics collector for Apache Cassandra. We tend to call it MCAC. That also, the data that it collects, you can also export it to Prometheus and then eventually Grafana. Helps you monitor things like, disk utilization, CPU utilization, read and write metrics, read latencies, write latencies, heap utilization. It monitors lots of stuff. Let me ping the URL, hang on, in the chat.
Yep, I wanted to add what MCAC is a great tool which was open sourced recently, and now it's the really easiest way to collect the metrics information for the open source Apache Cassandra. Okay, guys, Eric, Jeremy, if I will have no luck with KataCoda, maybe you can show this workload with Grafana on your laptop.
I'll see if I can get that running in parallel.
Okay, great, thank you. So if you will be able to share your screen, when I will put your screen over mine and show how it works from your laptop.
Okay, let's see if this goes, and then I'll start to do the prep for this in the background.
Okay, while it starts, I wanted to have a word on KataCoda in general. So it's not starting too quick for me, but in general, just for you to know, there are very many of different courses and materials you may want to see regarding Kubernetes as well, and some continuous integration you definitely may be interested, and so on and so forth. And of course, DataStax uses these uses KataCoda a lot, so we can see what there are a lot of courses, what also may be useful for you to see. DataStax. Well, yeah, by DataStax, that's what I'm looking for. And there are very many different things regarding Astra, about Apache Kafka connector for Cassandra, about Kubernetes operator for Cassandra, and so on and so forth. So a lot of things you may want to see, and much more actually regarding the things what may be interesting for you, like snitches. Okay, we are moving some content there, grouping that, so it's going to be available in some moments. Jeremy, how it goes? Could you show us how it works?
I'm running it actually locally, but let me get it into the KataCoda. I think is probably better. Like what?
Locally, and share your screen and Skype, and I will put your screen over mine so people will see it. So no need to run it in KataCoda.
So, are you in yours? Let's see. And it's still loading on KataCoda for you. Okay. So let me share my screen on Skype then.
As soon as you're ready, just tell me.
I'll be right back. I can't share my screen on Skype until I restart it. So one second.
So sorry for the delay, but at least now you see it's a real live workshop. No cheating, no videos, but a real live workshop. And there is the price to pay for the workshops like that.
So let's see. Let me try and share.
Yes, everything is okay. Are you ready to share your screen?
Yes. Let me see if I can get this into a new window so it's not going to interfere.
Good, give me a moment. Share it screen.
Oh, it looks like it's running now.
Wait a second.
Are you running it, Eric? Are you running it, Eric?
Am I running? Sorry, again?
I think Eric is running it at this point as well.
Eric, are you sharing your screen?
Yep. So I'm sharing.
Okay.
And it's running at the moment. I'm just waiting for Grafana to come up.
But yes, it seems
like it's a problem on the KataCoda end. But hopefully everyone can see the screen.
Yeah, why don't I share my screen really quick and see if that helps. So take a look here.
Okay.
If you can see on my screen.
Yes, we can see your screen.
Yep.
Okay. So we have some distributions. We have the client overhead here. So we have the execute, the bind, the read input. So it's kind of laying it out in terms of each individual request, what's taking the time. So the execute is taking the most time of 200 microseconds. You have the cycle count. You can see it's always increasing because we're always going up. The service time distribution, and the different percentiles, and then the time range. So the max is, so the CQL IoT max is going to be at 173 milliseconds, and the min is 2 milliseconds. So you get an idea of some of the metrics that are being collected from NoSQL Bench as it's executing, and those get exported to here. One thing that we found in other places is you can do some tagging or some annotations within Grafana as well. So if like you're running a load and you're completing the ramp up load and you say, I'm going to bed, this is what we did for some sizing tech testing, is I'm going to go to bed, I'm going to have it ramp up and create like 1 billion data points. And then from that point, I'm going to create from 1 billion to 10 billion data points to have like the main course of running. You can put in annotations to say, okay, I'm done with it. The ramp up, and I'm going into the main, and you can put the annotations inside Grafana as well. So hopefully this gives some idea of. Let me put this out of the way. Let's see. Some of these don't really have a good basis for our discussion here, but we can see in this one, the service time range, the ramp up max of 416 milliseconds. And then you can kind of decompose that to say the execution and the bind take so much of the time. So if you're wondering what's taking the majority of the time in each step.
So just to go through some of the graphs in that dashboard that Jeremy's showing. So the ops graph in the top left is the rate of reads and writes per second that's happening on the cluster that NoSQL Bench is recording. The second one is the error count. Now, because we're running it locally and there's only a single node in the back end, we don't expect any error counts to show up. So that's something that's really important, because if you're seeing errors on the dashboard, the Grafana dashboard, you really need to investigate on the back end, meaning that you need to investigate on the Cassandra side of things, that if any of the nodes, for example, can't cope with the amount of writes that NoSQL Bench is sending it. So that's something that you need to be aware of. The service time is the percentiles of the data that the metrics that are getting collected. So it's how quickly your Cassandra database, based on the benchmarking that you're doing against the table, it's how quickly it's responding to the requests. So typically you don't want to see anything that takes more than 1 second. I think in Jeremy's example, he's showing that it's topping out at 400 milliseconds, which in Cassandra terms, that's slow.
Yeah, I have a lot running on my laptop right now.
And then the fourth one in the top right there. So this is a graph that's really important. You never want to see the optimize distribution to be more than 1, because if it's more than 1, it means that NoSQL bench is retrying the requests, meaning that there's something wrong with the cluster, that it has to retry, whether it's nodes are unresponsive or the disks can't keep up with the writes. You never want to see it more than 1.
And then these are the decomposed client overhead for the P75 and the P99 requests. So if we want to expand that. So it provides a sanity check to ensure that the client processing time is low and predictable. So in case you're wondering about, like, is it the overhead that's causing the problems in this case, or the latency, you can do kind of a real-time trace to see what's taking the time.
Okay, so I think we are done with this step. Jeremy, Eric, do you want to show anything else regarding the Grafana?
Maybe just to point out that the bottom right, the cycle count, is a nice one as well to kind of observe. So you should see that the graph, the trajectory is that it's growing. So for example, if you were doing like 1 million cycles, you should see that, it grows up and goes up to 1 million. Because if it doesn't, again, there's something's gone wrong with your benchmarking.
Okay, and I have a question. We use Ops Center. Is it possible to replicate the same? I think I know the answer, but still.
Not directly. So you're not exporting. So Grafana is more of a general purpose metrics collection system, whereas Ops Center monitors generally just Cassandra, the cluster itself. And so Ops Center is not going to be able to do like the NoSQL bench metrics themselves. That's more for something that's external to Cassandra. You can monitor Cassandra with Grafana, but you can also monitor other processes like this tool that's acting as a kind of a proxy application to Cassandra. And that's what it's really measuring at this point. This is the service time that each request is taking.
And it wouldn't make sense to do so, right? Because what we're doing with NoSQL Bench is that you're benchmarking against your database. You don't normally run benchmarking in production. So you wouldn't want that data to be populated in Ops Center because, it doesn't make sense.
But I would maybe adjust the question. I think it's not so much about the Ops Center by itself, but more about DataStax Enterprise. So could I use NoSQL Bench with DataStax Enterprise?
Yes,
you can use it with. Go on, Jeremy.
This is how we do internal testing against DataStax Enterprise and Cassandra. We've open sourced this so the Cassandra ecosystem can do regular testing against Cassandra as well. So whenever we have a large customer that has a very specific use case and they're trying to say, I want to generate this load with 5 data centers and this specific data model, we can go ahead and simulate all of the specifics about that situation, taking down data centers, taking down links, and that sort of thing. So NoSQL Bench is very good at that sort of use case.
Okay, great, thank you. So, and let's move on. So I'm switching back to my screen. Yep, welcome back. We did exercise metrics with Grafana, half with KataCoda, half locally. Thanks, Jeremy, again. And moving back to the next steps. Then all we did was prepare it. So thanks everyone working at the workshop to prepare all we need to show how NoSQL Bench works, but we want to do some steps on our own. And now finally we want to do custom workloads. So I already have my custom workloads screen prepared, and I hope it's not dead like it was last time. Very well. So it's a new scenario in KataCoda NoSQL Bench custom workloads. And first thing we are going to do is to extract a workload. The benchmarking workloads we run in previous scenarios were prepackaged, so you download them kinda together with the NoSQL Bench. In this scenario, we will build our own workload. First thing we have to do is we have to execute a node tool status to ensure our Cassandra is up and running. And it looks like it's up and running. Now we will list workloads to see what we have in the prepackaged workloads. Jeremy, let me move you a little bit so we will not hide the data. Sorry. So yes, now Jeremy will not hide the data from you. Good. And we have a list of the workloads included here. So what we see in the output. First, activities baseline SQL IoT DSE. IoT workload, which more optimal for DataStax Enterprise. Next one, activities baseline SQL IoT workload emulates a time series data model and access patterns. What is a time series data model? Everything what relates to the data arriving like from the time event, for example, reports from sensors in IoT, for example, but there are very many time series data. Workload with
stock taker.
Again?
Stock taker is another example of IO time series data.
Yep.
So anything that you're constantly writing stuff with, you're not updating it.
Yes, that's about more writes than reads and low amount of updates. We have activities baselines SQL key value. It's a key value based workload, so not the most used way maybe with Cassandra, but still known use case. SQL tabular workload with partitions, clusters, and data fields. Kinda a traditional workload for Cassandra, I would say. Activities MongoDB basic UID. Activities MongoDB basic. So again, NoSQL Bench is not about Cassandra, or at least not only about Cassandra. Using proper drivers, we can test nearly every NoSQL database you can imagine. And that's what we have here. I'm a bit curious why it's so small. Give me a moment. It's noops. Get back. Get back. Yes, better. Good. So I will open text a bit more. Very well. Now, what we are going to do, we are going to extract an existing workload. So we will not create a new one out from nothing, but we will use existing workload. To do so, we go with NoSQL Bench, copy SQL IoT. It's done. And now I'm going to inspect the extracted file. So that's the SQL IoT file. I'm opening it right here. So, and we see some things explaining this file. And well, there is no need to explain what's the description. I guess everyone understands. We have two scenarios here, default and Astra. Default you could guess as the main scenario we run here, and Astra if you want to run it with Astra database, not with the local Cassandra node. We have some bindings preparation, what will be the ID, what will be sensor name, station ID, and so on. And we have some blocks, so face schema defined, and how exactly to prepare the schema. So we create key space and we create table. That's the face schema. And we prepare everything we need. In schema Astra looks a little bit different. Then ramp up, we will write with consistency level local quorum, and we insert some data, define it in the bindings. Some verifications we may need, and that's the face main. And we define here a ratio and consistency level, and statements we are going to execute. And that was the read part, because in the IoT scenario in this case, you not only write but you also read. But that's I guess mostly going to be write active scenario. And well, you see, read ratio is going to be 1 and write ratio is going to be 9. So we write much more when we read. And here the exact steps we are going to do to make the insert statements, and that's the whole SQL IoT file workload. It's basically 137 lines, and it's pretty simple. It may look not so obvious in the beginning, but you will get used to it, and it gives you nearly unlimited ways to test your database for these kind of issues. And now we can execute this workload with the following. So I'm running nb.sqliot. Stop. No, I want it to run with the progress. Yes.
So just while you're doing that, Alex, maybe we can explain how the bindings are used in the statements.
You can make that larger, like make that.
Yes. Give me a second. I will make it larger and you will explain that.
So for each variable,
I think you
that
can go
is
on.
going to be inserted into the database. Yeah, if you can see that, okay. For each variable that's inserted into the database, you have things like hash line to string. So what it does is each binding takes as an input the cycle, and then it takes that cycle and then runs it through the method, like you've highlighted. The sensor name is a hash line to string, and so it takes the cycle, the current cycle that you're on of the 10 million cycles or whatever, and then uses that as a hash line to string. So it says whatever the cycle was, get that line of the variable words text file. And then you can do mods, you can do distributions. So the sensor value is going to take the cycle that you're currently on, and then take the normal distribution between 0 and 5, and then add 100. So it's going to be between the 100 and 105 for that cycle, or for that value. You have about 100 different stations that you're operating on, and then 10,000 different sources within that station, I believe. And then you have basically a payload of data at the bottom. And so just to try to say, there needs to be a little bit more payload than just these values. So it could have some deeper sensor value, but this is just kind of trying to emulate that. The time is the elapsed time. Let's see. If you want to chime in here too, Eric, I'm trying to just remember.
Yeah,
exactly
so if you just scroll down a tiny bit, Alex, just so we can show some of the statements and how the bindings are used in the statements themselves.
Sure.
So just
in
scroll.
The statements themselves.
Oh, sorry. Yep. So here we've got the insert happening. So see how you've got the curly brackets in the value section of the insert statement? So this is the actual CQL. And it substitutes, so for example, for the machine ID, it substitutes the output of the function that's in the bindings defined for that machine ID column. And similarly for the select statement a little bit further down on the screen, it does the same thing. So when it constructs the filter for the select statement, again, it uses the bindings for the different columns. And those are the CQL statements that get run by NoSQL Bench.
Right. And what I was describing above is how it takes whatever cycle that you're currently on and translating that to data that would be indicative of whatever data you're trying to emulate or simulate.
And we've got a question from Discord from DL. So the question was, how do I see the DDLs? Remember at the very start, we had the driver equals std. It will show you the actual CQL statements that will get run if you specify that, as opposed to driver equals CQL.
Yeah, it's kind of like a dry run.
Right. And question on YouTube, how do we do it against our existing application workload? You can, in fact, run it against your existing data.
Right. You can run it against your data, or you can generate data like what this is doing. The other thing that you can do is it's not just meant for working against Cassandra directly. What you can also do is there's an activity type of Kafka, and so you can integrate with Kafka, and I think that there's something to you write out to the port, and then the port intercepts that, and then adds that to the Kafka topic, I believe, something like that. We've integrated it with Kafka and Spark streaming as well, to be able to ingest, essentially simulate ingestion of data through Kafka and Spark streaming in batches.
Yep, great. And I wanted to add one more thing regarding the execution of this file and execution of workloads with NoSQL Bench. Do you remember in the very beginning, at the first steps at KataCoda, we first prepared schema when we ramped it up with the data, and then we do the main test, the main phase. So when you run NoSQL Bench without any phases specified, that's it will do a full scenario, all the steps identified here. But when you work with the existing data, when you don't need to do the schema creation or the ramp up, then you just may want to use only the main scenario without creating of anything, and then you can run it specifying the tag phase phase like that's. Let me scroll. Yes, face main directly, going to the exact workload with testing. Good. So I think I will switch back. Very well.
And just an item of note, what you mentioned earlier, I just wanted to highlight as well, is to say that when you look at the ratio, within that phase, the main phase, for instance, you'll have read steps and write steps, and you can combine the reads and writes in a single phase, and then the ratio is, like you said, there's 9 writes to 1 read in the IoT sense. But if we looked at the key value or the tabular, the CQL tabular YAML, it would probably be more evenly distributed between the reads and the writes, for instance. And you can combine multiple reads to say, if I have microservices that are doing different types of reads against the same data, you can put those in the same phase as well, so that you can simulate exactly what your application would be doing at any given time.
Good. So now we are going to create a test schema. The first thing a workload wants to do is to create the necessary tables for the benchmark. Let's build an example workload to create the IoT key space and tables. Alpha, you would normally start with an existing file and modify it. In this example, we are going to build the file from scratch so we can discuss each piece.
Just checking again, Alex. So I think we've lost sound. Can you just give us a thumbs up if it's back on?
Sound should be good now.
Thanks.
Good. So, first we are going to open SQL IoT basic schema YAML, which is pretty empty, and that's how it should be. And then they put the comment at the top of the file which shows how to run the workload and the description of the workload. And it's very simple. It just defines the description and a comment explaining how to run this file. But we cannot execute this file yet because it has only description defined. So we want to have something more. Then we are going to add some more things we may need here. So we need to add some blocks. Good. And we define the tags and face schema. It looks better. And we will need params prepared false. So we will not use prepared statements. Good. And finally, oh my god, it works very slowly.
Right, you're not using prepared statements to create the schema, is kind of what that means.
Yep. And I have to copy the statements. Yes, good. So I have tags defined for this block, and a parameter defined, and I have some statements. So I will have statements to create key space. I have statements to create key space, create table, and truncate table in case we will not need it anymore. And I want to run this workload file, so I first have to stop the previous one. Okay, it's almost done. Hey there. Yeah, NoSQL Bench is very busy running my previous workload, so doesn't want to stop it. Hey, enough.
Just while Alex is doing that, we've got, for those who are staying, so we've only got a few minutes left. So for those who are staying, we've got an AMA session, so you can ask us anything. We'll stay for another half an hour. We'll do a quick break after the session, and then we'll go for another half an hour, and you can ask us anything during that half an hour.
You are very right. We are almost out of time. That's the last workload. That's the last thing we want to show you today, but we have something special for you with David, and I want you to see that before you leave. So I will stop this presentation for a second and show you what David prepared for you, because it's very important to see. We discussed it a lot in the past, how important is to make not only proper data model, but also usage of this model. And the first rule of Cassandra is do not use allow filtering in production. So David prepared something for you to see, like why exactly. And with NoSQL Bench is a great tool to visualize, well, not visualize, to run this workload. And with Grafana, we can see how exactly it affects the system. So we have 5 minutes before the scheduled time. I want to show this thing, and I want you to see it because it's very, very, very important.
So in this example, I'm going to use NoSQL Bench to kind of tease out what might happen in a case where I want to performance test against a data model, one with my normal correct query access pattern using a correct partition key in my select statement, and another using an anti-pattern with allow filtering. And this is one of the really neat features of NoSQL Bench. It allows me to run a scenario where I can compare both of these access patterns in the same performance run to see what this does to the performance of my database. Now in this particular case, I have a 6-node Cassandra cluster that's running, and I just want to point out that the data load on this cluster is not very big, right? I don't even have a terabyte of data in the full cluster, and this is a 6-node cluster, so that's actually pretty big for the amount of data that I have. Now I'm using NoSQL Bench right now to actually run a scenario where I am writing many thousands of operations a second, or I'm also writing and reading to the database, and that's what we're seeing here. So we can look at our write latency, our read latency, and such. Now what I want to do though is I want to kick off a phase that I've created for an anti-pattern. Now I'm just going to let that run for a moment. While that's running, I'm going to explain something. So if you take a look at this particular command line parameter, you'll see this workload CQL IoT killer video. And within it, I am talking to one of the hosts that's in my cluster over here. And this tags equals phase main anti, right? What this is about. So I'm going to the main anti phase of this file. So what I'm going to do is I'm going to look here. This is the CQL IoT killer video YAML. I just want to point out that there is a phase called main anti. Here we go. And check this out. So right above it is the regular main phase. That's the one that I was just running a moment ago when we looked at the metrics. Notice here that, again, we have a select statement against some table, but the machine ID and the sensor name are my partition keys. They're a composite key, and I'm using them properly. In the second one, though, notice I have my phase main anti. Look what we're doing here, though. This time, in my where clause, I'm not actually providing something that is in my key at all, and I'm using allow filtering to allow it to run. Otherwise, it would give me an error. And that's what I'm running right now. So the real fun is to see what kind of difference will I see in my data. Now, again, because this is all configured in a single workload file in NoSQL Bench, I can very easily switch between these different patterns to see what'll happen. Okay, so now the data does lag behind just a little bit, but you can already start to see that I have an uptick here. My amount of range slices and my coordinator range read latency. You can see that this went from being essentially a flat line, right, for this whole run that I did until a nice uptick. And you can see that this is actually starting to come up as well. How about if I pull this down to 5 minutes? It's also interesting to note that the amount of reads and writes that I'm able to perform have also dropped off, right? So if you notice before, I had a good clip going with these, but now they have dropped off significantly. You can see now as well that my read latency is starting to go up. Okay, so now that a little time has elapsed, notice that the read latency has increased significantly, up to 6 seconds and even 4 seconds for our P95s. That's really pretty high. And you'll see the same thing for our write latency, and again, the decrease in the amount of operations we're actually able to handle. So I can stop that scenario and then just switch it back over to the main scenario. And as that runs, then the data will come down. You'll see that the read latency will drop as we go back to, again, a correct query pattern as compared to the anti-pattern that we brought into play. And so that's it. Just wanted to illustrate one way that you can use NoSQL Bench to help kind of explore different query access patterns all in one go while looking at the metrics for your Cassandra cluster.
Okay, I think we are back, and many thanks to David. Okay, I think we are back, and many thanks. Okay, sorry for the sound.
One thing. Can I interject one thing?
Yeah.
So I think that not only can you test your data model, but you can also test the cluster as it, well, obviously as it relates to the data model and the patterns of data querying that you're going to do, such as what David just showed. But also, if you're trying to burn in your cluster as well, you can use one of the baked-in activities to say, is my cluster tuned correctly? And so you could say, for CQL IoT, CQL key value, CQL tabular, you can run that and then change a setting in your cluster to say, what if I change the compaction throughput in my Cassandra.yaml? Will that make a difference in terms of how the cluster performs? You can do that and then change that and then run one of these baked-in scenarios, or you can run one of the scenarios that more matches your use case and see if that makes a difference in terms of throughput or in query latency, as David was describing.
Yep, thank you. So we are start to get a bit out of time, but you've seen all the most important things today. So now we just want to show the end up with the custom workload. We prepared already the first block. So don't forget, NoSQL Bench workload consists of blocks, and we just define it in this tiny file. The first block, which has a tag, face schema, which has parameter prepared false, and 3 statements defined: create space, create key space, create table, and truncate table. And we want to execute that, and I run it with NoSQL Bench run driver SQL workload, specifying my file, threads auto, and cycles free, so it's not going to be too active, and it will create key space and create table for me. And accordingly to, I have no errors so far. It will be fine for me, and I have it's executed. Good. We can try to take a look at the logs. Okay. Yes. And log is general going to be like that. Some reports. For us now it's not important. The main thing, no errors. So yes, everything is executed. And first block of our custom workload works well. Let's move on then. Now we are going to write some test data. So we have schema, but schema is not enough to do some testing. So we want to put some data into the schema. When benchmarking, we are attempting to emulate the normal performance, how it looks like with a realistic or almost realistic workload. This includes access patterns, data density per node, and many other factors. So the ramp up phase brings the test system to the situation of the loaded data and be ready for the test. And now we want to build an example ramp up workload file. So before, the workloads we had was in a single file, but now we want to isolate them to keep them simple and readable. So now SQL IoT basic schema is our schema file, and we are going to have SQL IoT basic ramp up YAML file. So it will have data creation steps. And we put a description to it. It's going to be the same simple description. Workload emulates a time series data model and ramps up data after schema creation. Good. Now we define again a block. So block is the main entity for us, and it will have a tag phase ramp up. So we can specify this phase. And we have to prepare the bindings. Bindings were explained already by our great speakers, and bindings are basically the data we are going to use, and for different kinds of data we are going to use different kinds of bindings. And in the insert ramp up we have only one simple statement, inserting the required data in the consistency level local quorum. So we don't need anything else. And now we are going to have this executed. So we created the schema already, and now we want this schema to be loaded with the data. And I run this command. So it will be NoSQL bench run Cassandra query language driver. Workload is basic ramp up, the file we just created. Threads auto, cycles 100,000, and put progress to the console. So what we are doing right now, we are inserting the test data. Which particular data is defined in the bindings. How exactly do we insert that? Using the insert ramp up statement. So it may take some time, but in the end we have our workloads executed and all the data is inserted. Gentlemen, we may need some time to put the data in, so maybe there are any questions you would answer. Eric, Jeremy, are there any questions you would answer?
There aren't any at the moment, just waiting for anyone if you've got any questions.
Okay, but we are mostly done. Okay, so it doesn't matter, we are good. Yes, so this step is completed, and we created the schema at the previous step, and we loaded the data at this step, so we can move on. And this one is going to be the step 4, and we are very close to the end. Now we are going to create a SQL IoT basic main file. And it's completely empty, but we start to put the content. So let's take a look what we have right now. We have a file, very short one with a description, and one block is defined. This block is tagged. It will have tag phase main. It has some bindings, So machine ID and sensor name, and this way we indicate a read workload at the system. So select read, select all from baselines IoT, the machine ID is and sensor name is. We are reading IoT data given we know machine ID and sensor name. Very well. Oops. Yes. And when I run this workload, what I do, so I run using driver SQL, I specify the workload, SQL IoT basic main, that's the file we created, and for now it executes only read workload, reading the data we created before in the ramp up phase. Meanwhile, I can close old files. Oops. Okay. Okay, KataCoda is not happy with me today.
All right, how about we take a quick break and then be back for questions.
Yes. Meanwhile, let us have a 5 minutes break, and I will prepare all the steps to show you the last step of this scenario. So 5 minutes break. It's now, I don't know your hour, but I know your time, hopefully. For me, it's 11:10. And consider your time. We meet again 5 minutes later, and I will create the workload for us to run the last step of this example. Welcome back, Eric. Very on time. Okay, so it's 11:16 for me. That means what 5 minutes break is over. And we are going to proceed. And meanwhile, I've just finished it with SQL IoT basic main file. So this workload I've prepared with the read-only workload was successfully executed. And finally, I can show you the last step of the workload we are doing. Yes, putting it all together. So at this point, you could actually stop with the schema, ramp up in main phase files and simply work with those. You could execute those workloads with the following commands and everything would work fine. We use IoT basic schema YAML to define the schema. We can use IoT basic ramp up file to load schema with the data. And we can use SQL IoT basic main to execute the read-only scenario. And we put that to 3 different files because we wanted to keep them small and understandable. And each file defines one block. So altogether, we see what the workload consists of 3 blocks. And now we want to build some more, as we have SQL IoT basic all YAML file. And that's basically all what we have, but with some more kind of data and united together. And now we can run this file specifying the tags. So for example, instead of running different files at a different time, I can use this file specifying the exact step I want to execute. For example, in this case, I want to execute workload. I specify my united file SQL IoT basic all, but I specify the tag and I want to use ramp up only, so it will only load data for me, for example. And now we may define the different blocks and different scenarios. So let me scroll down a little bit. Oops. And I will stop this one because we don't need it right now. Yes, good. And I'm going to add one more line. Well, not one more line, but some more lines. I'm adding scenarios. Scenarios allow me to define, well, scenarios. It's the easiest way to explain that. And yes, one block is redundant. I have to remove that. And now I have a default scenario. So I may not only run the simple step specifying a tag or the whole file, but I can simply run this file, and as I have the default scenario, it will do all the things and it knows what exactly to do. So I specify to run, first I run schema block with some settings. Second, I run the ramp up block with some settings. And finally, I run main block with some settings. And then I can execute these just specifying the scenario name. So I'm running this file SQL IoT basic all, with all the phases we united together. I specify the scenario I want to execute, and I ask to put the progress to the console with every 1 second. And basically, we are done with this topic. Congratulations. So, and the very last steps. Last point, homework. We want your homework to be very simple this time because you did a great work over all the last weeks. So first thing we do the exercises of week 7. So that's you do it all in KataCoda, just what I did right now, or you do it with locally. And validation form of the week. Link to the validation form of the week should be in the video description under us at the YouTube. But if you, I hope you have it there. If it's not delivered there, then you know where to ask, because we have, well, these materials at the community.datastacks.com. Astracaton reminder, Astracaton is going in. We have 4 weeks to build real Cassandra applications, and date is now set after the 8-week workshop, August 20th. So we have not so much time, 1 week left, so you're going to do your work quickly, and it's going to be over at 12 p.m. PST. PST is Pacific Standard Time, I believe. And August 26th, we will do an Ask Me, Ask You Anything special episode, last episode of the Cassandra Workshop series, with a lot of surprises, and we announce winners, and we have a lot of fun. And we are done for today. We stay here for 10-15 more minutes to answer all the questions, and we are very happy to have you with us. Thank you for joining us, and let's get some questions answered.
So really good question from Krishna. So can we handle as part of the benchmarking using NoSQL bench? So that's a really good one. So typically what you would do is you would run a benchmark against your data model without encryption enabled, and then after you've completed that run, you do another. You set up encryption, and then you run another benchmarking, and then you can compare. So typically, depending on the stuff that you do, it can range anywhere from 10 to 15% overhead. I think in my experience. It's usually more that it's going to be CPU bound. The other constant question that we keep getting asked: when are we gonna do an operations or an administrator workshop? Yes, that's in the works. That it seems like there's a high demand for it. But like I said, when we were doing the Kubernetes workshops. The future is not in being an administrator, because you can easily be replaced with a Kubernetes operator now. What you do installing Cassandra, configuring Cassandra, deploying Cassandra, maintaining Cassandra, all of that can now be done with a Kubernetes operator. You've been replaced by software. So if you want to have a future in Cassandra, you need to be a developer. In any technology, really, not just Cassandra.
So I have to strongly disagree at this point. We can say what artificial intelligence could replace operations or developers, but it may happen only in one case, when managers or customers will be able to explain their requirements in a clear, obvious, simple manner. And from my experience, it's going to happen approximately never. So I do think what operations and developers, all of us, will be still required in the future. But future will show. there is a question, would it be a good idea to get into Kubernetes when? Well, we see what the future is in the clouds, and we see what many companies migrate more and more people start to use microservices and containers and so on. And currently it looks like Docker Swarm has lost this competition, and Kubernetes is definitely the industry standard to run orchestration and management over data centers with containers. So it's definitely a good idea, at least to understand what's the Kubernetes and how it's going to work. I cannot recommend you all to jump to Kubernetes because, well, it's not for every project, let's say, but at least understand what is it and what it does and why you may need that. That's definitely a very good idea.
Lots of companies keep asking us how to deploy in a Kubernetes cluster. It's a in thing at the moment.
And one more thing, we keep talking about the Kubernetes, but it's like talking about the very high level things, although we still have low level things to cover, and you cannot successfully manage a Kubernetes if you don't understand what's the Docker and what's the Docker container is. And we are about to run a next series, much shorter than this one, a Docker dedicated. So we will walk through the Docker things in a quiet pace, with no hurry, with no pressure, like we did for this workshop series, trying to push all the knowledge in the world to your poor brains. It will be much slower, and we will cover from the very beginning what a container, why you may need that, how Docker works, how do you use that, what's the Docker compose and when you need that, and then finally when you may need the Kubernetes and how you develop applications with Docker, because I've seen so many companies using Docker in so weird way, following all the possible anti-patterns working with Docker. So we will cover things like that. This course is not announced yet, but we are about to announce that, so I expect it to start somewhere in the middle of September, maybe end of September, and I expect it to take approximately 4 weeks. So it will be introduction to Docker and getting deeper with Docker. Yes, two people asked us how do we subscribe for these kind of things, and answer is, first, follow us at the YouTube and like our workshops at the YouTube. That's a great motivator for us to keep doing the things, your subscriptions and your likes. That's very close to Erick. There is a button under the Ramirez subscribe and like, and you have to press this button. Thank you. Yes, and the second thing, if anyone would be able to get the link to our Eventbrite page. On the Eventbrite, that's the main page for us to announce all the events. And we have, you can go to eventbrite.com. I can actually show you as long as I'm sharing my screen. Yes, that's the Eventbrite, and there is a data stacks. And we have some events coming in. So Cassandra Cloud Native Workshop Series is the one you attending right now. There is a Chinese specific event dedicated for Cassandra version 4 tomorrow, but well, most of you I guess don't speak Chinese. If you do, that's a very good place to do. And you can press the follow button here and you will receive notifications of our upcoming events. And if we don't have any more questions, I would end up with that. Okay, I see the last question. Can we expect Cassandra related webinar which mainly focuses on the administration tasks? Kumar, Manish. So thank you for the question. We receive a lot of questions like that. We work to deliver this kind of content as well, because Cassandra administration, especially at scale, is not easy. So far, I can only recommend. Give me a moment. Okay. So far, I can only recommend academy.datastacks.com. There is a course for maintenance and operations. Eric, do you remember the number of this course? It was DS
201 for foundations and 210 for operations.
210 for operations. It explains a lot, and now it's the best place to learn the operation and maintenance with Cassandra. Any more questions? We are about to end for today.
So
thanks very much again for joining us this week. Really good to see we've got huge support out there. People that attend every single week.
And I have last question for today. I'm from Oracle DBA background. We are getting into NoSQL stuff now, learning it on our own and doing some proof of concepts. So an optimal path would be learn container Kubernetes, then NoSQL. My answer is, well, maybe Eric has his own answer. My answer is no. Those two are very different lanes, very different ways. So you can do only one of them. You can do both of them. You can do one by one. You can do at the same time. They aren't directly related to each other. So you can do Cassandra completely with containers. You can do Cassandra completely without Kubernetes. It's not related technically anyhow. And
right.
Whatever is more
it
important
doesn't solve
for
your
you
problems.
to start.
Learning containers doesn't solve it. Learning about containers and Kubernetes doesn't solve your NoSQL problem. So focus on NoSQL if that's the problem that you're trying to solve.
Yes, this way. So I would. There are no dependencies on these paths, and you can start with NoSQL, proceed with containerization, or start with containerization, then proceed to NoSQL. Those are very different fields. They aren't related directly, I would say.
All right.
I think that's it.
Yes, I think we are done for today. Okay, the owl is typing maybe the last one. We don't have a concrete problem to solve, just self-learning. Thanks again for the info. Well, my position, you have to learn both a bit to be an up-to-date developer or be up-to-date DBA. Yeah, thank you all for attending. Sorry for some sound issues. We will fix them by the next workshop. And it was a big pleasure to be with all of you here. Thank you for coming. Thank you for answering questions. Thank you for being with us, and see you next week. Ciao.